In this question, we've got the unit vector I going in the east direction. That's the positive x direction for us normally. And j going north. So that tallies up well. Distance is measured in meters, time in seconds. Then we've got a ship, 100,000 kilograms being towed by 2 tugboats. Cables attached are horizontal. One tug produces a force of this and the other of this. And then we've got a total resistance to motion of 200 newtons. At the instant when it begins to tow the ship, it's moving east at a speed of 1.5 meters per second. So first of all, we need to explain why the ship continues to move directly east. And I'm going to take a look at the resultant force from the tugboats. I'm going to write it in vector form, so it's going to be 350, 400 plus 250 minus 400, which gives 600 and then 0. And this means the resultant force is east. I actually went into more detail than I think was expected. I then talked about the resistance. The resistance will oppose this. So we've got our ship. We've got 600 here, and 200 will be going in the opposite direction. The overall resultant force is 400 newtons east. So the ship will continue in this direction or continue east. Now this is more than expected, as long as you said that they cancel out in the north and south directions essentially, or that the resultant is east, then you're okay. But I don't know, I think it's good to be, it's good to write more rather than not enough. In B, we're asked to find the acceleration of the ship. And actually, I've done all this extra stuff, but it's going to be useful now because I can just apply F equals ma this way. And then I've got my 400 because I've already spent some time calculating it. 400 is going to equal 100,000 because that was the weight of the ship times A. So A is 400 divided by 100,000. And that gives 0.004 meters per second squared. Finally, in part C, we're asked to find the time which the ship takes to move 400 meters while it's being towed, and then find the speed after moving that distance. So as you can see, we've got constant acceleration, and therefore I can apply the Suvat equations. Okay, so it's going to be, I've not defined it, but it's going to be the time from which it's being towed up to it moving 400 meters. So S is 400. And we're also told earlier on that the initial speed was 1.5. Therefore, I can find t. I can use S equals ut plus half at squared. Rearrange to make the 0.02 t squared first. And I'm just going to use the quadratic formula in the classroom's calculator to do it as easily as possible. So I get 208.63 or negative. So reject this one. I always think it's just good practice. Reject it on physical grounds. You don't need to write that. And therefore, to three significant figures, t is equal to 209 seconds. Okay, we've got that, and we're asked to find the velocity at that point. Now, there's two ways you can do this. You could use the time that we just calculated, but if you've made a mistake there, then that can impact on the next answer. So actually, I'm going to do it without. I'm going to use v squared equals u squared plus 2as. And that's using these three quantities we were given earlier. So v equals the square root of u squared plus 2as, which is going to be 1.5 squared plus 0.008. I've done it, it might be safer to just let your calculator deal with that, times 400. And I've ignored the negative solution right from the start. I can just put this straight in my calculator. .3345, which rounds to 2.33 meters per second. Now, one final check that is worth doing is maybe just check that we get the same time if we use this v. So v is equal to u plus at. And that is another way you could have done this question, actually. You could have worked out v, a little bit easier to solve, and then substituted in to get t. But I think doing it this way is quite good because this, it really just checks that the answer's right, because t is going to be v minus u over a. So it's going to be that 2.33. I can use the answer button for that, minus 1.5 from before, and then a, remember, was 0.004. So I get that 209 from before. If I'd accidentally made a mistake along the way, I could have then potentially found it. So I'm not going to write any more there, but it's just a little check. Don't need to write it down in the exam or anything, but just to check to be 100% sure. Well done.